Right triangle trigonometry lesson, we need a right triangle, which I happen to have here. We're going to call this vertex C, which therefore now this is angle C. And since this side, which is the hypotenuse, is across from angle C, we call that little c, which is going to be known as our hypotenuse. We'll need two more angles. We'll call that B, and we'll call this A. If we call this A, then this will now be known as side A over here. And if this is B, then opposite of side angle B will be side B, which we'll use lowercase b. Now, for this problem, I need at least some make-believe numbers. We'll call side A 5. We'll call side B 6. And then side C can't be make-believe. Actually, as long as I have two sides, the third side can't be make-believe because remember, a squared plus b squared equals c squared, thanks to Pythagorean's theorem. So therefore, if 5 squared plus 6 squared has to equal c squared in this particular problem, then I know that c is going to have to be the square root of 61. So now that I'm going to try to solve my problem, which is sine of a, or maybe the next problem will be cosine of a, or my third problem will be tangent of a, I have to realize that what I'm being asked is, let's take a look at this from a function box perspective. In goes my angle. Now, what is my angle? Well, that I right now do not know. I do not know what the angle is. But honestly, I do not know, and to be really realistic, do not care. Because what I'm only interested in is the ratio. That is what I'm interested in. And so to get that, I'm going to be looking for ratios as my answers, which requires me to understand that sine of A, as taught before, is opposite over hypotenuse. So once I establish that A is my angle, which is going to be right here, this, by definition, would be my opposite. Since my opposite is 5, let's get that in this spot, and my hypotenuse is radical 61, bingo, I have my answer. That's all I ever cared about. If I'm going to do cosine of A, then I need to know it is the adjacent over the hypotenuse. Those are the two sides that determine it. Since B, or side B specifically, would be my adjacent because it's the one side that's not the hypotenuse that's actually like attached to angle A, I just look up that ratio. I say it's 6 to radical 61. I have my second ratio, then my second answer. Finally, tangent of A is opposite over adjacent. Again, look at my triangle. I have 5. I have 6. Boom, done. Don't need anything more than that. However, if I'm going to start looking at something a little different, let me go up here. I need to do some erasing. If I want to get rid of, let's say, angle A per se, and focus on what is going to be angle B, which I'm going to put in a different color here. Hopefully you can tell. Here's B, and I'm going to look at this, B for blue. You have to remember that the hypotenuse is still the hypotenuse. Ooh, that's interesting. I actually accidentally erased my Y. That's not good. But what's now saying is side B here is officially now my opposite, and A is now my adjacent. So if I was to do some problems over here and I said, what is my sine of B? Now my ratio is going to be 6 over radical 61, which is kind of interesting because that happens to be the same as the cosine of A. So let's write that over here. Cosine of A. The question is, why is that the case? That would be known as the complements theorem. The complements theorem goes back to the last chapter, which says that if you take the sine of an angle subtracted from pi over 2, which in this case would also be 90 degrees, it would equal the cosine of the original angle. So if A happens to be our original angle here, then B would be 90 degrees minus A. And therefore, these two angles added together, A plus B, would equal 90 degrees. And that's why the complements theorem is actually such a big deal, because what is one person's opposite would, in this case for angle A, be another one's adjacent. So now, if I was to do cosine, where's my pen? There we go. cosine of b. I would look at the adjacent, which in this case is 5 over radical 61, and realize there's my answer, which ironically also happens to be the sine of a. Let's write that as an a now, because again, cosine of pi over 2 minus theta would equal the sine of the original theta. Finally, if I was to do tangent, let's see if I can squeeze in a little bit more room here. Tangent of a. That's just a case of taking the opposite, which is 6, over the adjacent, which is 5, and I have my answer. Again, when I'm being asked to take a sine of an angle, or a cosine of an angle, or a tangent of an angle, I am being asked for a ratio. Now in this case, I'm writing them as fractions. If I want to write them as decimals, you could. In this case, it would be pretty easy. This would be just 1.2. For the second example, let's look at this young couple where this young beau is serenading this young woman here, and overhead flies an airplane, of course, because nothing is more romantic than an airplane flying overhead. First thing I need to do is, once I figure out where my mouse is, I'm going to draw a line. We're going to use her line of sight. We're going to look straight ahead. A little off, but you get the idea. We're going to call this her horizontal. It should be, well, slope of 0, but you get the idea. And what I'm going to do now is I'm going to draw another line representing her line of sight to the airplane. This angle that falls between here, let's draw this here, is called her angle of elevation. Okay, so that would be her angle of elevation. If we were to draw yet another line of sight, I'm not finding my mouse. There we go. And I draw a line down to her bow to his eyesight. Okay, we're going to now right here. This would be this angle here, down here, would be known as the angle of depression. Now, the reason it's called angle depression is because it's essentially below, it's depressed into the earth, and it has nothing to do with the quality of his singing ability. So if I was actually try to figure out a couple problems here, let's say hypothetically, just give me a moment here, I'm going to have to erase some stuff here. I said erase, not add. Okay. If I wanted to figure out, let's say, how far her bow is from a horizontal position. Where's my pen? I would need to essentially draw a triangle straight down. This would be a right triangle. So I'm going to recreate that over here. Here's my right triangle. It goes out to her eye. Then we connect to his eye down here. And let's say that I know that they are vertically, let's say, 6 feet apart. And I happen to know that the angle here happens to be roughly, let's say, 50 degrees. I'm just making these numbers up. If I wanted to know where horizontally how far away their eyes were from each other, then I would try to figure out what this x is. And because of that's x, I would realize that I have been given the opposite. I've been given, or I'm trying to find the adjacent. I have the angle there, so therefore that would be a good tangent problem, because I know that the tangent of 50 degrees is going to be opposite over adjacent. So in this case, tangent of 50 degrees equals 6 over x. If I was to solve this problem, I would go x tangent of 50 degrees after multiplying both sides by x, and then I would realize I'd still have to divide both sides by tangent of 50 degrees. Most likely you don't know tangent of 50 degrees from memory. 60 degrees yes, but 50 degrees no. So what we'll do is we'll click down here on the calculator. Looks like I was trying that out before, so let's clear this out. And I would go 6. I would divide it by, and then normally you would type in tangent first if this was the graphing calculator, but I have to type in 50. There we go, 50. I will hit tangent, You can see the problem here. D stands for degrees, and that's because it's in degree mode. You will see that normally a 50 degree is that the opposite will be 1.19175 times larger than the adjacent. If I hit enter, it tells me that their eyes horizontally apart are roughly 5.034597. I think we got more than enough decimal places. 5.034 feet apart. Since their eyes really aren't measured by how horizontal apart, but their actual distance would be, which is from here to here, we probably should get this measurement, which we'll call Z. And for that, because 6 is the opposite and Z is the hypotenuse, I think it would be better to say sine of 50 degrees is to 6 over, that's 6, over the Z. The work pretty much works out to be the same thing. Z equals 6 divided by sine of 50 degrees. But because the ratio is different, I come down here, I go 6. Let's clear this out. 6 divided by 50. Take the sine of that angle, which in this case, its ratio of a sine of 50 degrees means is that the opposite 0.766, it only goes up that high as you go at a diagonal of 1. I hit enter, and you find out that they are going to be, oops, there we go, 7.83 feet apart. Is that what it was? Yep, 7.83 feet apart. So they should be close enough to each other that she can hear, even if the singing is quite awful.